correlation and conditional mean. If the conditional mean of big Y does not depend on big X, then big Y and big X are uncorrelated. That is, if big E of big Y given big X equals mu sub big Y, then covariance of big Y and big X equals 0, and correlation of big Y and big X equals 0, equation 2.28. We now show this result. First, suppose big Y and big X have mean 0, so that covariance of big Y and big X equals big E, the expectation, open bracket, open big Y minus mu sub big Y, close, open big X minus mu sub big X, close bracket, equals big E of big Y and big X. By the law of iterated expectations, equation 2.20, big E of big Y, big X equals big E of open bracket, big E of big Y, big X given big X, close bracket, equals big E, open bracket, big E of big Y given big X multiplied by big X, close bracket, equals 0, because big E of big Y given big X equals 0. So covariance of big Y and big X equals 0. Equation 2.28 follows by substituting covariance big Y and big X equals 0 into the definition of correlation in equation 2.26. If big Y and big X do not have mean 0, subtract off their means, and then the preceding proof applies. It is not necessarily true, however, that if big X and big Y are uncorrelated, then the conditional mean of big Y given big X does not depend on big X. Said differently, it is possible for the conditional mean of big Y to be a function of big X, but for big Y and big X nonetheless to be uncorrelated. An example is given in exercise 2.23.